In Chapter 12, we're going to be talking about the different conic sections. And the first thing we need to know in Chapter 12 is what a conic section is. Our definition of a conic section is right here. It is a curve determined by the intersection of a plane with a double right cone. So you can see our pictures here. We have a double right cone, so two cones right on top of each other. And these are our four different types of conic sections. Our first one is a circle. You can see when this plane, think of it as that plane is slicing that cone right in half at the top there. It creates a circle where the plane and the cone meet. So that is why our first one here is a circle. Our second type of conic section is called an ellipse. And our ellipse is very similar to the circle, but instead of being cut parallel to the base up here, this is our base of our cone. That plane is cutting it parallel. Now that plane is tilted a little bit. And that creates an oval-like shape or an ellipse that looks like this. Let's try that again. Make a better ellipse. Okay. So we have a circle, an ellipse, and our next one is called a hyperbola. Sorry, that is spelled wrong. HP. Okay, a hyperbola, you notice, our cone is being cut on the top of our shape here and on the bottom. It's cut in two places and it creates kind of a U shape. So if we look here, we've got a U shape up here and a U shape down here. So when we draw our hyperbola down below, it looks like this, where it cuts. We have an upwards U shape on top and a downwards U shape on the bottom. So we get two curves for a hyperbola. And then our last one, it is just being cut in one spot again up here, but this time we're creating a similar U shape like a hyperbola, but it's only in that one spot. So we call this a parabola. And this is just one U shape. It's a little skinnier than a hyperbola would be. Hyperbola opens up wider and there's two of them. Parabola is a little skinnier and there's only one. So these are our four different types of conic sections that we're going to look at. So we are going to start down here with the parabola, and we already know what a parabola looks like, so I'm going to start by drawing that. We have a parabola that looks something, let's try that again. Something like this, as symmetrical as possible. We've got arrows on the top. Okay? So the first part of a parabola that I'm going to label is our point furthest at the bottom of our parabola, which we call the vertex. Okay, the second part I'm going to label in my parabola is called my axis of symmetry. So a parabola is going to be the same on both sides. So if we drew a line straight down the middle, cut it in half, it should mirror the other side. this right here, I'm cutting it in half. This is my axis of symmetry. And then there are two other things I'm going to draw these next two terms first, and then I'll explain them. So this right here is called our directrix. And this right here is called our focus. So what these two things are, our directrix and our focus. Our parabola relates to our directrix and our focus because any distance along this parabola, so if we pick this point right here in the middle, our distance from this point to the focus is going to be equal to the distance from this point to the directrix. So no matter where we are on this curve, that distance should be the same. So it might not look exactly right because I didn't draw this to scale, but if we picked a point here, this distance right here should be the same as this distance right here. And this distance right here would be the same right here, straight down to our directrix, would be the same as our distance to our focus. So that is what those two words mean, and those are all four of the words that we use to define the parts of a parabola. So I'm just going to list them over here on the side so that we have them all. We have our axis of symmetry, we have our focus and our directrix, and our vertex. So these are the four important things to remember for a parabola. Okay, so let's look at our next part. We have two different types of parabola. We could have a parabola with a vertical axis of symmetry. Vertical axis of symmetry means our axis of symmetry is straight up and down. It's vertical. And there are two cases where we could have a vertical axis of symmetry, so I'll draw them both. We could have a parabola with a vertex here, and our parabola is facing down. Or we could have a parabola like we drew above with our parabola facing up. Horizontal axis of symmetry, you can probably guess what that is going to look like. Again, we have two possibilities. We could have a parabola with our opening facing to the right, or we could have a horizontal axis of symmetry with the opening of our parabola facing to the left. So that's what we mean by horizontal axis of symmetry and vertical axis of symmetry. So let's look at an example of a parabola. This example says, using the graphs below, provide all of the listed information. So the first thing we want to find on this parabola is the vertex. And the vertex is the point on the parabola where it is on the axis of symmetry and the top of that curve. So this right here is our vertex. We can count our point. We go over 1, 2 on our x-axis here, 1, 2, and up 1. So our point is 2, 1. Sorry, I wrote that in the wrong spot. That goes in the vertex spot, 2, 1. Okay, our focus is labeled on here for us. We've got this point right here, and we need to find the coordinates of that point. So if we start on our x, we go over 1, 2, and we go down 1, 2. So that is positive 2, comma, negative 2. The next piece it asks for is axis of symmetry. So we know our axis of symmetry, it's labeled on here for us, divides that parabola in half. This is our line for our axis of symmetry. So this axis crosses our x-axis right here at 2. So that means x always equals 2. Our equation for that straight vertical line is x equals 2. And then our last one, our directrix. Again, it's drawn on here for us. It is that line equal from our focus. This line crosses our y-axis right here. So if we count up 1, 2, 3, 4, our line there is y equals 4. No matter where we are on that line, y always equals 4. So that is how we can write the equations of that line. So this is our answer for our parabola. The next conic section we're going to look at is an ellipse. So I drew our ellipse right here. And the first thing I'm going to do is draw in some lines so we can label our information. So we have a line going across this way and this way, dividing our ellipse in half in both directions. Our horizontal line here, you can tell that that horizontal line is longer. So this longer line we call our major axis. Put an arrow there. So we have a major axis along this way. And this line here, our shorter axis, is called our minor axis. So those are our first two vocab words when it comes to an ellipse. The next part of our ellipse is called our vertices. So our vertices mark the sharpest turns of our ellipse, or the kind of the edges of that ellipse. So our blue points here are all called vertices. There's no I there, vertices. And then our other point in an ellipse are called the focus, or plural of focus is foci. They are on our major axes, and all you need to know about the foci, or one of the focus, is that these points help us create the ellipse. So those are the 4 points, or sorry, 4 vocab words when it comes to the part of an ellipse. So then, very similar to the parabola, we have a vertical major axis. So that means our major axis is up and down. So our parabola, let's try that again. Looks like this. That major axis is straight up and down. Or we could have a horizontal major axis. So this looks like the example up top, where that major axis is horizontal. Okay, so let's look at an example finding our parts of an ellipse. First point it's looking for is the center, which we can see our center of the ellipse is right here, so we can find that point. We are going left this time on our axis, so that is going to be negative 1, 2, 3, 4. So our center is -4 in the x direction, and then up 1, 2, 3. +3 in our y. Now our foci, there are 2 of those. We have one right here and one right here. For this first one at the bottom, we're going over that same -4, 1, 2, 3, 4, and down 1. So our first one is -4, -1. And our second foci, we're going over -4 and up 1, 2, 3, 4, 5, 6, 7. -4, 7. Those are our 2 foci points. Then it says the length of the major axis. So if we draw in our major axis, that is the longer one right here, we can count how many points, or how long that line is. So if we start at this vertex, count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points between those 2 vertices. So our major axis is 10 units long. Then our minor axis, that is going through the center the other direction. Again, we can count from this point to this point how long that line is. We count 1, 2, 3, 4, 5, 6. Our minor axis is 6 units long. Then the last part wants our vertices. So we drew them already with our major and minor axis, but we can figure out those points here. So if we start at the bottom, count over -4 to the left and down 2. So our first one is going to be -4, -2. This point over here, we count over 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3. -7, 3. This one up here, we know that's -4 to the left, up 1, 2, 3, 4, 5, 6, 7, 8. -4, 8. And our last point, this vertex right here, we're going over 1. So our first point is -1, and up 1, 2, 3. So that is the answer for our example of a ellipse. Our next conic section is a hyperbola. So remember, a hyperbola is kind of like a parabola, but now we have 2 curves instead of 1. So I'm going to start by drawing our 2 curves. So we have one curve going upward and our other curve going downward. And now these shapes are, I'm going to draw this one again because these shapes are supposed to mirror each other. So they are the same curve, but one's going up, one's going down. So these are our hyperbola. The first point that I'm going to label for the hyperbola is the center. The center of our hyperbola is right in the middle. So this point right here is called the center. Then I'm going to draw in some lines for our hyperbola. So the first line I'm going to draw is straight down the middle. And the name for this line right here is called our transverse axis. this line goes straight down the center of the hyperbola and cuts each part of the hyperbola into two. The second axis goes the other direction. So this axis is where if you folded the hyperbola over on this line, it would be a mirror. Each part would be right on top of each other. This is called our conjugate axis. And then we have two other lines that we use with a hyperbola. And those two lines I will draw right here. So we have a line goes like this right here, a straight line this way and this way. Okay, so these two straight lines are called asymptotes. And you are not expected to memorize all these different words or what they are. You are expected to use your notes, look at these graphs, and be able to identify these parts on other graphs. So make sure when you're doing these questions, you're looking back at these examples to help you figure out which part is which. So these green lines here are asymptotes. These are used to help create our parabola. So you can see the x that it makes. The top of our parabola fits in between that x, and the bottom of our parabola here fits in between the x on the bottom. Okay, and then the next part I'm going to label is my focus of the parabola. And again, all you need to know about the focus, sorry, not parabola, I keep saying parabola, hyperbola. Hyperbola, the focus of my hyperbola is right here. All you need to know about those 2 points, the foci, is that these help determine where that hyperbola goes. Helps create the hyperbola focus. And then lastly, we have our vertex, or our vertices, which are the top and bottom of those curves. Those 2 points are our vertices. That is what we have for our vertices. Okay, so these are all the parts of a hyperbola. Just like our other conic sections, we can have a vertical transverse axis or a horizontal transverse axis. So remember, our transverse axis is this one right here when we have a hyperbola with an up and a down shape. So this is an example of a vertical transverse axis, and a horizontal transverse axis means that our hyperbola opens up to the left and to the right. Okay, so those are our vertical and horizontal options for the hyperbola. So now let's look at an example where we find the points of the different parts of our hyperbola. The center of our hyperbola is where our 2 asymptotes come together, right here. So if we look for that point, we go over 1, 2, 3 to the left. Means we have a -3, and down 1, 2, -2. Our vertices of our hyperbola are these points right here, the most curved part of our graph. So if we write the points for the vertices, our first point here is on our y-axis. That means our x value is 0, and we're going down 1, 2, -2. Then our other point over here, we're going over 1, 2, 3, 4, 5, 6. So we have -6 for our x, and then down 1, 2, -2. Okay, our foci are the points inside our hyperbola. Our first one on the right here, we going 1, 2, a +2, and down 1, 2, -2 for our y. And our other foci, we're going left 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2, -8, -2. Then the last thing it wants us to find is the slopes of the asymptotes. And remember, our asymptotes are the x lines through our hyperbola. So we've got one asymptote right here and one asymptote right here. Now to find the slope of the line, we just need to find 2 points on that line and find our rise over run. So if we have this point in our center right here, we can use that point. And then I need to find a point where it crosses. So it looks like it crosses right here. So if I start at my point on the left, I go up 1, 2, 3, 4. So my rise is 4, and then my run is 1, 2, 3. 4 over 3 is my first slope. To find my slope of the other asymptote, I'm going to use the point straight across from it here. So to find the rise over run of here, I'm starting at my left point here, so I'm going to start up here this time. I'm going down 1, 2, 3, 4. So this time I have a -4 and 1, 2, 3. Rise over run, -4 over 3. And you should always get slopes, opposite slopes for your asymptotes. So if you have 4/3 for the first slope, your other slope should be the negative. Our last conic section is the parts of a circle, and we have gone over this in our last chapter. But just to review, the parts that we're going to need to know for this section, we have a circle. We need to know the center of our circle, right here, center, and the radius. The radius is half the distance of our circle. And we label that as R most of the time. So if we look at our circle down here, we want to find the center and the radius. Center of our circle, that point is already on there for us. It is -1, 1. And then to find our radius of the circle, they drew this line in there for us, but I could also draw a radius straight across here. This line is much easier to find than this line right here, because my blue radius right here, I can just count the distance. I can count over 1, 2, 3.5. My radius is 3.5. Okay, so that is all of the different conic sections that we're going to be talking about. Make sure you use these notes on the homework. You are not going to remember these from learning them once, so make sure you look at the diagrams, look back at the different parts as you're answering the questions on the homework.